All right, so yesterday we found that geometric sequence, the formula for a sequence in geometric sequence is a of n, right? That's what we did yesterday. A of n was the first number times a rate, we figure out that rate, to the n minus 1. So in fact, I'll put parentheses on the n minus 1. That's what we did yesterday. I think I put a parentheses on the r. And then I even said the rate when I gave you guys a list. When I gave you guys a list, it was a number divided by the previous one. Right? That was yesterday. We still need to find out what's a first number and what's a rate. But now I'm giving you two random numbers. In this case, they happen to be consecutive, number 1 and number 2. So I'm just going to say that a of 2, so 12 is going to be a of 1, 3. So I'm going to do the latest one equals the first one times r. I don't know what the rate is, so I'm going to call it r. Then now my power, my exponent on r is going to be the difference between 2 and 1. Because I'm doing a of 2, a of 1. The difference between them. So I'm going to subtract those two numbers. The difference between them is my power of r. In this case, 1. But if my numbers was like a of 2 and a of 5, my power on r will be 3. Once again, the power, the exponent of r is the difference between which numbers are you looking at. The difference between them. Right? The difference between 2 and 1 is 1. Right? Subtract them. That's the exponent. Now solve for r. My case, I'm just going to divide both sides by 3 to get rid of the number in front of it. And I have the 4 is r to the 1. If r to the 1 is 4, I think we can just say that r is equal to 4, right? We know the rate. In this case, we know that the first number is 3. That was given. That was given to us. We know the first number is 3. We know that the rate is 4. We can find out any number we want on the list. We're looking for a of 10 in this case. So I'm going to say a of 10 is equal to the first number times 4. Right? My rate is 4. And in this case, I'm going to do 4 to the 9th. N minus 1. I'm just going to calculate this. I'm going to go 4 to the 9th. Let me grab my calculator in this case. I'm doing 4 to the 9th. It tells me it's 262,144. My result, I'm going to multiply it by 3. And it gives me 786,432. The first thing I have to do is my exponent. Remember, order operations, you do exponents before you multiply. You guys learned it as PEMDAS or GEMS. I don't know how you guys learned it. But you do exponents before you multiply. So we did 4 to the 9th times 3. We're good? Now, if I don't give you the first term, not this one. Let me take a look at this one. I'm just going to say, remembering the formula is a to the n is equal to the first term times a rate to the n minus 1. I need to find out what's the first term and what's the rate. I need to find out what's the first term and what's the rate. What number do I keep on multiplying? The rate is easy to find. I'm just going to say a of 2, or no, a of 3 in this case, because this is the latest one, negative 12 is equal to a numbered negative 6 times r, because I don't know the rate, I'm calling it r. Now, what's the difference between 3 and 2? What is it? 1, right? The difference between the numbers 3 and 2, that's my exponent. Solve for r. Let me divide both sides by negative 6. So I get that 2 is equal to r to the 1. We can just agree that r is equal to 2, right? We found r. We found the rate. Now, for me to find ace of 1, I don't have it. One way I'm going to find out ace of 1, I'm going to use any of these numbers. Let me use ace of 3. I can use whichever one I want. I'm going to use ace of 3 just to choose one. So negative 12. Keep in mind I'm using ace of 3. So from the first formula, I've already said n equals 1. I mean n equals 3. So negative 12 equals, I don't know what my first number is, so ace of 1 times 2, because that's the rate, to the 2. As soon as I said I'm using ace of 3, I already said from a formula on the very top, n equals 3, right? Because I'm using ace of 3. So I already said n equals 3. So that's how I came out with negative 12 equals ace of 1, which I don't know what ace of 1 is, times 2 to the second power. My rate, we found out the r is 2, because I'm using ace of 3, n minus 1 is 2. All right, so I have that negative 12 is equal to ace of 1 times 4. Notice I did the exponent, 2 to the second power. Now let me divide both sides by 4, and I'm going to find out that ace of 1 is negative 3. My first number is negative 3. Now that I have the first number and I have the rate, I can find out any number that I want. In this case, let me find out what ace of 9 is. Ace of 9 is equal to negative 3, which is the first number. Then I'm going to have 2 to the 8. All right, let me do 2 to the 8. It tells me it's 256, 2 to the 8 times negative 3. Then in this case, it tells me it is negative 768. Now, for your examples, by coincidence, these two numbers were continuous. Like on example 5, I gave you ace of 1 and ace of 2. On example 6, I gave you ace of 2 and ace of 3. Continuous numbers. Now, let me come out with a different example number 6, where my numbers are not continuous. I'm going to do ace of 2 and ace of 5. So I'm not doing continuous numbers. I know ace of n is equal to ace of 1 times times rate to the n minus 1. I need to find out what's my first number and what's my rate. So I'm doing a different example from the ones you guys have. I want my numbers to not be continuous. I'm going to find the rate. The way I'm going to find the rate, I'm going to say negative 256. I'm looking at ace of 5 is equal to 4 times the rate to the third power. And the r to the third power, because I subtracted ace of 5, ace of 2, the difference between them is 3. So I wanted to do something where my r was not to the 1 power. So let me divide both sides by 4. 256 divided by 4, well, negative 256 divided by 4 gives me negative 64 is equal to r to the third power. To solve for r, because it's r to the third power, I'm going to do the cube root. All right, r to the third, I'm going to do the cube root. You guys should have a key on your calculator that says the square root, the radical sign, and there's like an x because we don't know which root you're going to use. Some calculators said to the third power.